so part one of the inquiry, we're doing the online portion. It says, set the cannon height at 0 meters. So we open up this little thing. You can do that if you want to on your computer. It's fun to play with. So if you have a computer open, you know, click on it and open it up and do it yourself. Set the cannon height at 0 meters. So this cannon, it's the plus sign, see right here on the cannon. And that needs to be like almost like clear down the bottom like that. So it says 0 meters there. Okay. We're going to put the velocity at 30 meters per second. So I put it at 30. We have air resistance turned on. We're not doing anything with air resistance right now. It says you may have to zoom out. Okay, we already did that. You can zoom out is up here. Calculate. So the first thing we're going to do is we're going to calculate something before we test this. Calculate the maximum range. I want to know how far over I can shoot this thing. Okay, so now remember, right now we're shooting and landing on the same plane. This first part is shooting and landing on the same plane, right? So we're using
Herman, it's kind of weird again. You're going to want to stop sharing.
B squared over G times the sine of 2 theta. Remember that? And we want to figure out the farthest we could shoot at 30 meters per second. Okay? So what angle would that be? Because you have to just know that. What's the optimal angle of shooting and landing on the same plane? 45 degrees. And 2 times 45 is what? And sine of 90 is 1. So whenever we're trying to figure out the maximum range, it's a pretty easy equation. Square the velocity and divide by gravity. That's max. Now, of course, you need to know that you're shooting at 45 degrees so that you can get that maximum velocity. So we're going to do 30 squared divided by 9.81, and we're just doing positive 9.81 because there's technically a negative in the front of this. And I get like 91.7 meters should be the farthest I could shoot this thing. Does that make sense?
Yeah.
So I'm going to take the target, I'm going to move it out here to, oh, I'm going to have to really zoom out, I guess. 91.7, close. Oh. There we go. And this cannon needs to be at 45 degrees. Okay. 30 meters per second. Ready? And let's do it. There it goes. Come on. Come on. Oh, so satisfying. See those stars go up? So we made it. Okay, that's the farthest we can possibly shoot it. Okay? All right. What's next? It says, calculate the maximum range and test. Okay, we did that. Calculate the 2 angles. That will give you a range of 79.5 meters. So this time we actually already have a range. I'm going to move it to, let's see, erase that. 79.5. Okay. And there's 2 angles that are going to give this, and we want to figure out what they both are. So how do I do that? Got this equation here. And I need to solve for the angle, right? So I'm going to take the G times the other side, right? So it's going to be R times G. And I can then divide by the V squared. And that'll equal sine of 2 theta. Right? I'm trying to solve for the theta. How do I do this? How do I get out of this? What do I have to do to both sides? Inverse sine, right? So if I do the inverse sine of this, now it's going to be 2 times theta. And then I have inverse sine of RG over V squared, right? And so I could do this whole part over here, and then I'm going to have to divide by 2, right, to get the actual angle. So I can start putting stuff in. What was it? 79.5 was the range, right? 79.5 times 9.81 divide by 30 squared equals, and then I'm going to do inverse sine. Okay, and I'm going to divide that by 2. And I get an angle of basically 30 degrees. Okay, now there's 2 angles. That's one of them. Anybody know the other one? It'd be 60 degrees, right? Complementary angles. When you solve for theta in this equation, you're going to get the smaller one. Okay, you're going to get the smaller one. Okay, so let's try it. We're on 30 meters per second. We're going to move it to 30, and we're going to fire. And we got it. Isn't that fun?
Yeah.
It's more fun when we're doing it for real, with a real cannon and measuring it, shooting it, watching.
A real can? Do we have a real can?
I do. That's what this lab normally was.
Why aren't we doing that?
Because to do a hands-on activity in hybrid means you have to take a whole week to do it so that everybody can do it. Can't happen.
We could have like an after school get together where we
We
shoot
could.
cannonballs.
We could. That'd be fun. I
Yeah.
think they'd let me do that. Would everybody come?
I don't know.
I don't
I might
think so.
not, but
Probably not. You really suggested.
Everybody come except for Jake. Okay, so both of them worked, right? 30 and 60, they both hit the same spot. Okay, what else it says? Oh, it said, this is mean. For each angle, calculate the maximum height and the time of flight.
If you drag your cursor.
I know, but we're gonna calculate it. Right? So here we go. So I'm breaking this down. I get 30 and 60 degrees. So I have, we'll do 60 degrees. Okay, and this is 30 meters per second. And then we have, 30 meters per second again, but this time it's 30 degrees. This is really good to do this. This is good. This will really help. You're gonna get problems like this on the Jedi trial. So for this problem, I need to figure out, I need to break these up into components, right? Do I actually need the Vx in this problem? We're trying to find the maximum height. So it's going to go, it's going to go up like this and back down. So we're trying to find this height. And this one's going to go up and down. And we're trying to find this height. And we're also trying to find how much time it's in the air. I don't actually need Vx for either of those, right? The only thing I ever needed Vx for would be to find the range at the end by multiplying the time by the Vx. But I was given the range to begin with, right? So I don't have to use Vx at all. All I need is this component here. Now there is a component here. I'll just draw it in. But the only one I need is Vy. So this is 30 times 60 sine. So for this one, it's like 26. And this one is really easy. It's 15, right? Because sine of 30 is 1/2, right? Yeah. Okay. Okay. All right, so these are my vertical velocities. They're going to be my initial velocities, and I'm just going to use the uniform acceleration equations to figure out how high and how much time, right? Okay, so actually, I could, well, let's do it 2 different ways. So let's figure out how high it goes up right here. Which equation am I going to use to figure out how high in the air it goes? Right now, I don't have time, so there's 2 displacement equations. One of them has time in it. I don't want that one right now. Vf squared equals Vi squared plus 2AD, right? Okay, so the D is going to equal VF squared minus VI squared all over 2A, and A is gravity, right? Okay, what's the final velocity? We're looking to go all the way up to here. What's the final velocity up here? It's 0. Vertically, it's 0, right? Yes, it has a horizontal velocity. That's not part of this problem. Okay, those are independent of each other. So the final velocity up here is 0. So I could do, VF squared to be 0 minus 30. Nope, not 30. What's the initial velocity? Almost tricked myself. What's the initial velocity? It's 26, right? See, we're not using this anymore. Unless that was going straight up, we're not using that anymore. We're dividing it up into the Vx and Vy. So my initial velocity up is 26. So that'd be 26 squared over 2 times negative 9.81. I'll put that in there because we want to have a positive distance. So 26 squared divide by 2 and divide by 9.81. Right? Okay, equals my distance. This looks like it's 34 meters, 34 and a half meters maybe, height. Okay, I can do the same thing down here. It'd be 0 minus 15 squared divided by 2 times negative 9.81 would be my height. Boy, the last class, boy, they hated when I divided and then I divided again.
Yeah, why don't you?
Oh, they were so angry about it. It was like, man, vicious. It's like, it's math. You can do that. And I wanted the parentheses, Okay, so this one they only went 11 and a half meters in the air. This one went 34 meters in the air. Okay. How do I figure out how long this one here is in the air? How much time?
VF minus VI over A.
Okay, so I could do VF minus VI over A, which is G, right? Should equal the time. Okay. What is the final velocity for this one? Well, what's the initial velocity?
Is it negative 26?
Yeah, the initial velocity is 26, right? So the final velocity right here, the vertical would be a negative 26, right? That makes sense? This triangle is going to be over here just like this one's over here, right? So if my initial velocity up is 20, I'm throwing it up 26, it's going to hit the ground down at negative 26. Forget about that it's actually a parabola. Just pretend it's going straight up and straight down. That's what you need to do. Okay, so my initial velocity, so my final velocity is a negative 26 minus the starting is 26 divided by a negative 9.81. That'd be a negative 52 divided by negative 9.81. And the total time is like 5.3 seconds. All right. By the way, what's another way to figure out the time? Actually, there's 2 other ways you can figure out the time.
I like my way.
That was an easy way. That's the way I would do it too. That was really good. There actually is maybe an easier way almost. Remember I said we didn't need the Vx, but if we did have the Vx, right? Like on this problem here, the Vx would be 30 times 30 cosine. This Vx here is 26. Okay, yeah, should be same as that. 26. So remember, we actually knew the range, right? We were given the range from the beginning, weren't we? 79.5 meters, right? So if I have the horizontal velocity and the range, I can figure out how much time it takes to get over there, can I? V equals d over t. T would equal d over v. 79.5 divided by 26. That should give me my time. Right? I can do it the horizontal way, actually, just the constant velocity way. since I was already given the range. Normally you're not given the range yet on this. So again, you can, this would be negative 15 minus 15 over negative 9.81. So that'd be 30 divided by 9.81. Should be like 3.06 seconds. On that, or we can look at the thing and see if we're right. There's a little device here I can drag around. Height right there is 34.4. That's what we got, right? Good. And height here, 11.5. Good. Time, I'll go all the way to the end. Ooh, how am I going to do this? Okay, so in this one, it's a little over 3 seconds. Good. This one should be a little over 5.2. Yep. Okay, you can find the time and the height anywhere you want on this whole thing. All right, we good on part 1? That's part 1. All right, part 2. Set the cannon height at 15 meters. Whoops.
It's pretty, it's gonna go straight down.
Oh, there you go.
I've already tried to do that.
What happened?
Thought it would go back in. It doesn't. It actually goes all the way to the ground.
That's silly.
Oh, that's
That doesn't make sense.
I'll just do it real quick. I'll shoot it. There it goes. Oh, how long's it gonna be up there?
Oh no.
There it comes.
You gave it.
Oh.
Oh,
See?
that's so stupid.
Yeah, I know. I was hoping it would go in and would explode, like I
Yeah,
found, like
that would make
like an
sense.
Easter egg or
Just like
something.
God on that.
Really cool. I don't know what the guy is doing.
Are you supposed to try to hit the
Can you move
guy?
him?
Yo, we should
You
try
can't
and hit
even
him.
move him. I
I
have
bet
no
if you hit
idea.
him, something
Try to
happens.
hit
this
him.
time.
Really? Like
Try
blood
to
goes
hit him.
everywhere?
Yeah, we should
Oh,
try and calculate that.
that might be cool.
I don't think you have to calculate
You
it.
ever play the
Just aim it
kitty
right at
cannon?
him.
I was gonna try to do all this with the
Can you
kitty
aim it
cannon.
straight down, Mr. Herman? Try it. Can you aim it straight down? Like
I don't think I can.
Try to hit it.
Can I aim it now?
Oh.
Oh my gosh.
Just see what happens.
Oh! Took his head off.
He
His
just-
head's laying on the ground now.
Oh, is it actually?
No.
Oh, I was gonna say you look good.
Okay, all this is recorded. All right, set the cannon height at 15 meters, velocity at 30, and range at 87.1. Where'd my target go?
Zoom out.
Oh, clear out there, isn't it?
You zoomed in.
87 point 1. There we go. Okay, it says you may have to zoom out. Calculate the 2 angles that will hit the target. Calculate the
Isn't
2
this what we
angles
did
that will hit
yesterday?
the target. How should we do this?
Didn't we do this yesterday?
We really hope that we have our calculators on that day, right? And then we have a good program because we can just put it into the program, right? Figure out the 2 angles that are going to work. So, moment of truth. First of all, you got to find your calculator. There it is. Okay. So, program. I'm going to run it. Launch. Everybody try your own program. See if it works. Enter. And it says, hey, what's the velocity? And the velocity is 30. And I click enter and it says, what's the range? And I can't remember what it was. 87.1. 87.1. Enter. Okay. That is if you did your V and your R and your S. I don't know, did we did it in a different order? Or that was the order we did it, right? Okay. You got to keep your variables straight. So what is the S? It's negative 15 because I'm starting up here and I'm shooting down to a target down here. And that target is 15 meters below the level. Does that make sense? Okay, so you got to put in a negative 15, and I hit enter, and it tells me, are those right?
Yes, they are.
I hope so. About 60 and 20 should do it.
I got 0. You got 0?
They don't add up to 90. How come?
No. I'm so good at this.
Because we're not shooting and landing on the same plane. So that's important to remember, because people get tricked on the test sometimes. There's certain really easy questions on the test. If you understand shooting and landing on the same plane, I can ask you some straight up super easy questions, okay?
On the test it'll say, right?
Yeah, it'll say it lands on the same plane or something like that. But if it's not, if the planes are offset, okay, it's not as easy. It's not easy at all, okay? You gotta, I mean, if you're gonna find the angle, that's really tough. That's why we made a program for it, okay? Because everybody always missed those all the time. Somewhere in the quadratic, they would get lost and never could get the answer, so.
You used to make them do it by hand?
Well, I mean, I just didn't tell them how to program it.
Yeah.
I said, you can program this in your calculator if you want, but no one had ever learned.
Yeah, because you couldn't even.
Everything has to be so teacher directed, it seems like, you know, it's like people learn on your own. Jake's good at learning on his own. I'll give
You
him
messed
credit.
up the program when you tried to do it. How
What?
would they know how to do it?
Oh, yeah, I guess I messed up myself, didn't I? That's embarrassing. Okay, so 60 and 20 is supposed to do it. So let's do this. Moment of truth. Oh, I'm already at 60 degrees. That's perfect. Okay, here we go. Let's see. There it goes. Come on.
It's right.
Boom. And 20 degrees should also work. By the way, like if I move this in here, well, sometimes, you know, depending on where the target is, you might end up getting like a negative angle, because you would actually, there's two angles that'll work. One is still shooting up, and the other one is like just shooting down into it. Okay, so that could happen. Don't freak out if you get something like that. So it'd be a possibility. Great, they worked. Okay, it also says for both angles, calculate the maximum height and the total times of flight. We got to do it again. All right, but this time we're not shooting landing on the same plane. So we're going at 60 degrees.
You don't have your thing.
Guess I should show you what I'm writing. Okay. We're going to go up like this, and then we're coming all the way down to here. So technically down to here is a negative 15. This is 30. Let's see, I already calculated these. What were they? I'm going to do it again. 30.
26.
24? 26?
26.
26, right? And this one was then 30? I mean 15, I mean, it can't be 30. 15, right? Okay, so we want to find the height. How do we find the height? VF squared minus VI squared, right? Divided by 2 and divided by the gravity. And we already did this, didn't we? Didn't we already do this problem?
Yeah, but with
We just add we could add on 15, right? Okay, because we got it from, technically we did this part of the problem, right? Okay, so we just add on the 15 to get that total height. Okay, what about the total time? Okay, so here is, I want us to look at this for a second here. I have two equations that have time in it. VF equals VF equals AT plus VI, right? And then I have D equals VIT plus 1/2 AT squared. Correct? Now on this one, we're not going to cheat on this one. Technically, I know what the range is, right? I already know what the range is, and I know what Vx is. So that'd be the super easy way to figure out the time. But we're pretending right now we don't maybe know what the range is. How can I find the time of flight of something that does not land and shoot on the same plane? If it lands and shoots on the same plane, I'm using this. There's just no question about it. I'm going to go ahead and use this because the VF would be a negative 26 and the initial velocity, the positive 26, right? The one you were saying to do. And gravity, we know it, so it would be able to solve for time. I could actually even use this. If I'm shooting and landing on the same plane, I could use this because what can I put in for D? 0, right? And then I could divide everything by a time, right? So you'd have a 0 VI plus 1/2 AT. And so that'd be 2 times, we take your VI over here, it'd be a negative 2 times VI divided by negative 9.81 would be my time. And that would actually be the same answer as this, right? This is going to end up being negative 2 VI over negative 9.81 also, right? VF, I'll just show you. VF minus VI over A equals T. VF down is negative what VI was, right? So it'd be like negative VI minus VI over gravity equals T. This is the same thing. Either equation gives me the exact same thing, okay? But if I'm not shooting and landing on the same plane, I can't put a 0 in for D. I got to put a negative 15 in for D, right? And that makes this problem not fun, right? Because it's a quadratic now, and you got to solve your quadratic for time, okay? Now, you don't have to do that. I'm going to show you why you don't have to do that. Some of you have figured this out already, I think. So there's another, so I could still, this is the one that you wanted to use, right? VF equals AT plus VI, right? We wanted to use this. How come we can't use this in this problem though? We don't know our final, we don't know what our final velocity is like right here. So we can't use that. Okay, so what we have been doing in the past is we're going to use this. We're going to put in negative 15, right? Equals initial velocity is 26t plus 1/2 negative 9.81 times t squared. And then we do 0, and we'd have, you know, negative 4.905 t squared plus 26t plus 15, and you have ax squared plus bx plus c, right? So you have a b, and a c. You have to put that in the quadratic, and you get 2 possible times, okay? Where we would be at the negative 15. One of those times is going to be a negative. It's going to be like, you know, back here in time, which you can't do. So you'd reject the negative answer. That's not physics possible. You would take the positive answer for time. Right? Now that's not that hard because by now I'm sure most of you have just already programmed in the quadratic formula right into your calculators. Instead of using, so that's finding time using the one equation. If you don't like the quadratic stuff, you could have always found the time just using 2 of the equations instead of the 1. I want to use this to find the time. But to use this, I need the final velocity. So let's use this other equation, right, to find the final velocity. Once we find the final velocity, we put it in here, and now we can get the time. Because this isn't bad, right? It's already kind of set up. VF squared equals my initial velocity is 26 squared plus 2, negative 9.81. Times the negative 15 is my overall displacement. So I can quickly find the final velocity right here. And then I can do the time like everybody likes to do it, using this one. Okay, so you never really had to use a quadratic when you find the time. You could just use the other 2 equations instead. Find the final velocity and plug it in for this one and find the time. That makes sense or not? I have a feeling I lost people. I see some kind of inquisitive, like.
Good. All good.
Like your dog looking at you like, what? Okay, I don't know. That's that. Did we ever figure out the time? Or,
No.
we never did. Okay. Let's do it this way. So let's do 26 squared plus 2 times 9.81 negative times 15 negative equals square root. Final velocity is like 31. So I'm going to plug it in here. I'm going to do 31. That's it. That should have been a, oh, it's a negative 31. That's the trick on that. That's the problem on that one. That's a good thing I did it that way, pointed that out. Because when you square root something, what do you got?
Positive.
There's two possible answers when you square root something, right? There's 31, but there's also negative 31, and that's where your physics has to kick in and know that, the answer actually was negative 31 because it's going down. So that would have been a mistake, right? And you would have noticed right away when you did it in here because you would end up getting 0 for this, and that wouldn't have worked, right? So VF minus VI over, well, you wouldn't have got 0, I guess, because that's 26, but divided by negative 9.81 equals the time. So I'm going to have 31 negative minus 26 divided by 9.81 negative. Time is like 5.8 seconds. All right. So let's see.
I
wrote
forgot.
it down and then it went away.
What was it?
5.8 seconds,
What was
is that what
it?
it was?
Total height was 49.4. I think that's what we had.
No,
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 it was
no,
the time.
the time.
That's
Total
what you
time
said.
was 5.8 seconds.
Okay.
Yeah, that's what it says. 5.8 seconds. You need that.
Did we already figure out the max height?
What'd you say?
Did we already figure out the max height for this?
Yeah. So we did it in the last problem, and this height was, what was it? 34. I can't remember.
Yes,
what it was.
34.
Remember, we did it on this first part, and that's still the same, 34. But what we did is technically we just added 15 onto it, right? So you can find the height of this thing pretty easy from wherever you're at. 20 sine or 30 sine of 20. 30 times 20 sine. This is a 10.3. And 30 times 20 cosine. This is a 28.2. The range was still what, 87.1? So I'm going to go ahead and cheat and still figure out the time by doing 87.1 divided by 28.2. And it was 3.09 seconds. That makes much more sense because that's kind of what it showed me it was. Okay, and then we need the height. So the height is going to be, we're going to use VF squared equals VI squared plus 2AD. VF squared minus VI squared over 2 gravity should equal to D. So the final velocity up here is 0. So 0 minus initial velocity is 10.3. 10.3 squared. I'm going to divide that by 2, and I'm going to divide it by 9.81 negative. And I get a D of 5.4. We're going to add on 15. Should be like 24 meters from the ground.
20.4?
Where
Should
did
be.
15 come from?
The 15 is the cannon's already 15 meters up from the ground.
Oh, gotcha.
So I just figured out, initial velocity going up and final velocity is 0. So how high is it right here? And that was like 5.4 meters up. Okay, but it comes all the way down here, hits the ground here, that's 15 more meters. So. Yes. So if I came right here to the top, 20.4, that's what we got. Okay, so it's only like from this line right here up to there is like 5 meters, and then it's 15 all the way down to the ground. All right. Okay. That's the interactive. There's 2 inquiry questions. So 335 feet down the right field line, assuming the release points of a ball and the home run fence are the same height. Okay, so we're going to throw a ball. We're on home plate. We're going to throw a ball down the right field line, and the release point of the ball will say is the same height as the fence. Okay, so I can just, you know, I'm throwing here, and I'm trying to go right to there. Okay, basically I want to throw the ball out of the park, throw it over the home run fence. You know, I'm standing at home plate. All right, how fast in miles per hour would a person standing on home plate have to throw a ball to get it to go over the fence? I want to find out the velocity. How? I was just contemplating this one day at Busch Stadium. I thought, I wonder how fast I'd have to throw it.
Are
Okay.
you serious?
So, how do I do that? Put it on what thing? The animation thing? How do I calculate it? Well, basically I'm trying to throw it as far as I possibly can, right? At whatever velocity I have. So what angle should I be throwing it at?
45 degrees.
Yeah, if you're going to try to throw something as far as you can and try to get over a fence, you're going to throw it at 45 degrees, right?
Yeah,
That's what you're going to try to do.
Right.
Okay? So I know that the range is v squared over g, right? Times the sine of 2 theta. And if I put in 45 degrees times 2, that's 90. Sine of 90 is 1. This is the maximum range that I can throw at a given velocity, right? So v squared equals the range times gravity, and the velocity I would need to throw it at would be the square root of the range times gravity. Does that make sense? I'm trying to figure out, you know, what velocity I need to throw to get it out of there. So I'm going to throw it at 45 degrees, so I can use the, you know, smallest velocity I need. Okay? I mean, I might be able to throw it out at 60 degrees too, but I'm going to have to throw it a lot faster to have that happen. Okay? So now obviously this is in feet, so 1 meter is 3.28 feet. So 335 feet, 1 meter, 3.28 feet. We want that to be in meters. So 335 divided by 3.28 is my meters. That's the range. So square root of 102, close enough, times 9.81, right? And then I'm going to square root that. And I get a velocity of 31.7. That's meters per second. So I want to know in miles per hour. So 1 mile per hour is 0.447 meters per second. We're going to use that a lot, by the way, coming up. So there's a conversion factor to maybe memorize. So 31.7 divided by 0.447 equals 71 miles per hour.
Oh my God.
Here's an airplane flying along, and right now it's at an altitude or a height of 5,800 meters. Okay, 5,800 meters. It's gonna drop a bomb or something, less warfare sounding. A cat. It's gonna drop a cat. Okay, and it's trying to hit a target over here with the cat. Okay, trying to hit the target. So how far away from the target should the plane be when the pilot releases the cat? So they, you know, they can figure out how far they are away from this, you know, line here, and they need to know, okay, right now I have to drop it so that the cat, you know, the cat's going to fall out. It's going to come take a trajectory and it needs to hit. Okay, So I want to figure out how far away am I, which is right here. This is called the range, right? Okay, how do we do this? It says the plane is flying at 57.4 meters per second. That's that way. I need to figure out the range. Let's think this backwards. How will I figure out the range? How will I eventually know the range? How far over it goes? Just think simple. I mean, how do I figure out how have I every time, how have I eventually figured out the range?
Like B squared over G.
No, that is an equation that we came up with to make our lives a little bit easier, but that's all about the projectile thing. These problems here are doing the actual math, dividing things up into horizontals, vertical stuff.
You have to use the Vx.
Yeah, the Vx times t. That's how you get a horizontal range. You take your velocity that way times the time that's in the air, right? Vx times t. That's like every time it's been that way. Vx times t. All I need to know is the horizontal velocity of the cat, and I need to know the time. One of these I already know. Which one do I already know? I know the horizontal velocity of the cat because it's the horizontal velocity of the plane, right? And the cat's in the plane. So the cat's going just as fast as this. And when I drop it, guess what? Assuming there's no air resistance, okay? Not necessarily. Sometimes cats can.
Yeah, they learn the feet.
He would know.
Sometimes they can land on their feet. They don't always.
No, I feel like they always.
No. If you take a cat and you go like that with it,
Okay.
then it won't land on its feet.
Trust
Trust me.
No. Another
Okay.
probably should be recording.
You should.
Oh, yeah. That's not good. Okay. Edit cat dead joke. Okay. All right. So I know that the cat horizontal is going at 57.4 meters per second. So all I need to know is how long does it take the cat to hit the ground? That's all I need. How long does it take the cat to hit the ground? I don't care that it's hitting over here. Basically, how long does it take a cat to fall 5,800 meters? We've done that problem 1,000 times, right? Tell me an equation that would allow us to figure that out. Falling from rest, right? It's falling from rest, vertically, it's falling from rest. How long will it take something to fall down 5,800 meters? Which equation should I use?
Is it initial minus, wait, negative initial minus initial over gravity?
No, there's three equations.
Okay.
Vf squared equals Vi squared plus 2AD. Vf equals AT plus Vi. D equals VIT plus 1/2 AT squared. You need to know all three of those again for this Jedi trap. That's what we're using. These are the ones we're using. Okay. Now, yes, twice we've made some crazy derivation for some big problem so that we don't have to use these. That's what we've done. We made a big equation for shooting and landing on the same plane. We made a big equation for finding the angle if you don't land on the same plane. But all these other problems on your Jedi trial are going to be these. That's what they are. It's just not always going up and down anymore. Now you can go this way too. So we separate them all out. And I want to find out how much time does it take to fall down this far? Which equation do I use? We've done this problem a million times. Number one, it needs a time in it, right? There's only two equations that have a time in it. This one has a time in it. This one has a time in it. Which one?
I like the VF one better. So
This one?
That's it.
Can we use this one?
Yes.
Do I know the final velocity down here at the bottom?
Darn it.
Maybe.
Nope, I don't.
Zero.
You need to.
This
use
is
the
why I
new one.
failed
I gotta use this one.
Because it's falling from
I
rest.
gotta use this one. Because it's falling from rest. So this will go away, right? So D equals 1/2 gravity times squared. That's 2 times D divided by gravity square root will equal the time. Hope you follow that algebra quickly.
What? Whoa. You just, okay.
Here's the equation I used, but I don't need that first part because initial velocity is 0. It's falling from rest. So D equals 1/2 AT squared. If I solve for time, that's the square root of 2D over gravity. So 2 times 5,800 2 times 5,800 divided by 9.81 square root. The time is going to be like 34 seconds, 34.4 seconds to hit the ground. Now, every single second, it's going to go 57.4 meters over, right? That's why how we figure out the range. We take that horizontal push times how long it's in the air. So all we need to do to find the range is find out how long is it in the air. And then once you know that, just take it times your horizontal velocity and you'll have your distance over, right? 34.4. You're going to get a problem like this on the test. You're going to get a plane problem on the test. Okay? This is an easy problem. And I'm trying to convince people that it is really easy problem. Okay? And so I put one on the test for you. So 34.4 times 57.4, I get a 1975 meters. Better just cross it off. Okay? So if you get a plane flying, you want to find out how far the target is going to be away when you should drop it. Okay? All you do is find out how long it takes to fall that far, right? Find out how long, whatever the number is here, how long does it take to fall, whatever your altitude is, and that's going to be the time that the cat's in the air. So then just take that time times how fast the cat's moving that way. Just a quick little two-step problem, that's all it is. Does that make sense or not? You get that? It's not that bad, right?